Concorde was not just an airliner. It was a flying symbol of a future people thought was inevitable. While ordinary jets crossed the Atlantic in long, tiring hours, Concorde could do it at roughly twice the speed of sound. It made distance feel negotiable. A passenger could leave Europe and arrive in New York with much of the day still ahead. For business leaders, celebrities, diplomats, and the ultra-wealthy, that was more than convenience. It was status, speed, and spectacle in one narrow white aircraft. But Concorde's story is not simply about how fast humans managed to fly. It is about what happens when engineering brilliance meets the limits of money, noise, regulation, and real-world demand. The roots of Concorde go back to the 1950s, when the jet age was still young and governments believed aviation would keep getting faster. Britain and France saw supersonic passenger travel as a national prestige project, not just a business opportunity. In 1962, the two countries signed a treaty to develop the aircraft together, joining British and French engineering into one ambitious program. Early cost estimates were already enormous, but still far below what the project eventually consumed. The goal was radical: build a passenger aircraft that could operate safely on airline schedules while flying faster than sound for long periods. This was not an experimental rocket plane. It had to carry paying customers, use airports, meet certification rules, and work repeatedly in commercial service. Concorde's shape came directly from the physics of supersonic flight. Its fuselage was long and narrow, with a four-abreast cabin carrying far fewer passengers than large subsonic airliners. That was not an accident. At Mach 2, drag becomes a brutal enemy, and every unnecessary surface or widening of the body costs fuel and performance. The aircraft's famous ogival delta wing gave it stability and lift across very different speed ranges, from takeoff to high-altitude supersonic cruise. But the same design created awkward handling near the ground. Concorde landed at a high nose-up angle, so pilots needed the distinctive droop nose to see the runway. Even its most iconic visual feature was really a practical engineering solution. The engines were just as specialized as the airframe. Concorde used four Rolls-Royce and Snecma Olympus 593 turbojets, powerful machines designed for an environment ordinary airliner engines never faced. During takeoff and acceleration through the sound barrier, the aircraft used reheat, adding extra fuel into the exhaust stream for more thrust. That helped Concorde punch through the difficult transonic region, but it also burned fuel at a punishing rate. At supersonic speed, the air entering the engines had to be carefully controlled by variable intake ramps. Air arriving too fast or too unevenly could destabilize the engine. Concorde's speed was therefore not just about having powerful engines. It depended on precisely managing the invisible violence of airflow. Once at altitude, Concorde could do something extraordinary: supercruise across the ocean at twice the speed of sound. For much of a transatlantic flight, it did not merely touch supersonic speed for a moment. It stayed there, covering most of the route in a high-speed cruise that more than halved travel times. But flying that fast changed the aircraft itself. Air friction heated the skin, and the aluminium structure expanded during flight. Engineers had to design for heat, stress, fuel balance, and aerodynamic stability all at once. Concorde looked effortless from the cabin window, but its cruise was a carefully managed compromise between speed, materials, range, and safety. It was fast because every part of the aircraft was shaped around that single mission. Concorde was also advanced beneath the surface. It became the first airliner to use analog fly-by-wire flight controls, a major step in the evolution of modern aviation. Instead of relying only on direct mechanical links, pilot inputs were transmitted through electronic systems that helped control the aircraft's surfaces. That mattered because Concorde had to behave safely in two very different worlds: slow flight near airports and supersonic cruise high above the ocean. The aircraft was therefore not just a faster version of a normal jet. It was a bridge between old and new aviation technologies. Many ideas that seemed futuristic in Concorde later became normal in commercial aircraft, even though supersonic passenger travel itself did not become normal. At first, expectations were huge. Planners imagined a market for hundreds of aircraft, and major airlines showed interest. In the optimistic version of the future, Concorde would be the beginning of a global supersonic network. But the economics started to weaken before the aircraft even entered service. Development delays and cost overruns pushed the program into the billions. Fuel became more expensive. Environmental concerns became harder to ignore. And the sonic boom problem proved devastating. When an aircraft flies faster than sound, shock waves reach the ground as a loud boom. Overpopulated areas that made routine supersonic flight politically unacceptable. Concorde's greatest advantage could only be used mainly over oceans, cutting down the number of routes where it made sense. Concorde finally entered commercial service in January 1976 with Air France and British Airways. It was an instant prestige machine. Air France flew from Paris, while British Airways operated from London, and the aircraft soon focused on transatlantic routes. Washington and New York became central destinations because they matched Concorde's strengths: wealthy passengers, business urgency, and long ocean crossings where supersonic speed was allowed. But the narrow route network exposed the difference between fame and scale. Concorde was globally recognized, yet commercially limited. Only Air France and British Airways ever operated it as customers, with 7 airframes each. Total production reached just 20 aircraft, including prototypes and development models. It became one of the most famous airliners ever built while remaining one of the rarest. The passenger experience was luxurious, but not in the way modern travelers might imagine. Concorde did not offer giant private suites, wide beds, or huge onboard lounges. The cabin was narrow, and the aircraft carried a relatively small number of passengers, usually somewhere between 92 and 128 depending on configuration. The real luxury was time. Concorde sold hours back to people who valued them enormously. A normal wide-body jet could carry far more passengers at a much lower cost per seat, but Concorde offered something no ordinary aircraft could match: speed as exclusivity. That made it perfect for a small elite market, but difficult to expand. The more one looked at the numbers, the clearer it became that Concorde was not mass transportation. It was a premium time machine. Concorde's rivals reveal how difficult supersonic passenger aviation really was. The Soviet Tupolev Tu-144 reached passenger service, but only briefly, and a 1978 crash helped end that chapter. In the United States, Boeing's planned 2707 supersonic transport was even more ambitious, but it was cancelled before any prototype flew. These were not minor setbacks. They showed that the entire concept faced structural resistance. Supersonic airliners were expensive to build, expensive to operate, noisy, politically controversial, and vulnerable to fuel prices. Concorde survived because Britain and France had already committed heavily, and because Air France and British Airways could use it as a prestige flagship. It was not proof that the market was easy. It was proof that exceptional political and national will could keep one extraordinary aircraft alive. For most of its career, Concorde's safety reputation was strong. That changed on July 25, 2000, when Air France Flight 4590 crashed shortly after takeoff from Paris. All 109 people on board were killed, along with 4 people on the ground. It was the only fatal incident involving Concorde, but one accident was enough to permanently alter its image. Commercial flights were suspended while safety reviews and modifications took place. Service resumed in November 2001, yet the aircraft returned to a different world. The airline industry was under pressure, premium travel demand had weakened, and Concorde's maintenance costs were rising as the fleet aged. The crash did not single-handedly cause retirement, but it accelerated the end of an aircraft already fighting economic gravity. By 2003, Concorde was retired after 27 years of commercial operations. 18 of the 20 aircraft built were preserved, a remarkable survival rate that shows how deeply the aircraft captured public imagination. Museums did not treat Concorde as just another old jet. It became a monument to ambition, a reminder of an era when the future seemed faster by definition. But its legacy is complicated. Concorde proved that scheduled supersonic passenger travel was possible. It also proved that possible does not always mean sustainable. The aircraft was brilliant, beautiful, and technically successful in many ways. Yet it was too expensive, too route-limited, and too specialized to become ordinary. Concorde did not disappear because it failed to impress. It disappeared because the world around it chose practicality over speed. The lasting lesson of Concorde is that technology has to fit its environment. Engineers can build something astonishing, but airlines must operate it, regulators must approve it, passengers must pay for it, and communities must tolerate it. Concorde made the Atlantic feel smaller for a privileged few, but it could not reshape global aviation for everyone else. Today, new companies still dream about quieter, cleaner, more efficient supersonic travel, and Concorde remains their unavoidable reference point. It is both inspiration and warning. It shows what is possible when ambition is taken seriously, and what can happen when a machine is too far ahead of its market. Concorde was too fast to ignore, too elegant to forget, and too costly to last. If you found this helpful, please like this video and subscribe for more explainers.